We may be live. There we go. All right,
Yeah.
all. We are live today. We're doing a stream on a Monday, which is very different from almost all the other streams I've ever done. So we're doing a different stream today. This is not Crystal Fridays. It's not about the Crystal language, and it's definitely not Friday either. Today we're going to be talking about Go, which is a language that I have been involved with and in love with for years. And I am here with Jennifer Davis as well. And we're going to be talking together about Go today, specifically about a new Go feature that we'll get into. So, Jennifer, why don't you introduce yourself a little bit as well?
Awesome. So I'm Jennifer Davis. I'm a cloud advocate at Microsoft with the open source team with Ashley and McNamara, who is super awesome. I'm actually learning Go finally. Aaron has been super gracious in being my mentor in this, and we are going to explore generics today because that announcement came last week. So thank you so much, Aaron, for being willing to talk about just random things and Go.
For sure. We're really glad to have you here today. I'm really glad to have you here today. And yeah, I hope we will continue to do these going forward. But let's start today. Um, let's talk about the new design draft for type parameters. So,
Can we briefly talk about generics? Like, can you tell me what your thoughts about generics are? Like, what generics are?
yeah, for sure. So yeah, I mean, outside of Go, generics are obviously a thing that have been around for a while. So how do I say what generics are in a sentence? Do you have a good one sentence description, Jennifer?
I don't know that I have a good one sentence description, but yeah, I feel like if you actually look up generics, it's a very confusing like blob of text, which to me
Yeah.
means it's right for a space to be more clear because I think that informs like some of the discussions that people have about implementing and in a language. I know there's been a lot of arguments about whether Go actually needs generics or not, which is one of the reasons why I was really curious about your feelings and
Yeah.
insights.
All right. Well, I'm gonna give it a shot, a one sentence description, and then let me get into my feels. So, one sentence description: generics are a way for you to write a function or some code that lets anyone call it with any type they want, or at least almost any type they want. So, oh, hey, Gustavo. Thanks for joining from Brazil. Good to have you here. So yeah, that was one sentence. That was the best I got. So forgive me if that doesn't cover your favorite aspect of generics. It definitely doesn't cover everything.
If anybody has thoughts on what they think generics are, that would be great. You can share in the little chat window over there. Um,
For
if you're
sure.
new to Twitch, that's fine. So I was writing down some stuff because I was like thinking about this in a more specific kind of way. I know I did generics with Ada once upon a time,
Nice.
which kind
Nice.
of dates me a lot. And I don't know. There. So to me, it's kind of like a way to reduce duplication in your code, and there's a bunch of different ways that languages apparently call it in their language, like parametric polymorphism and templates and
Yeah.
parameterized types. And so I don't know, like I don't know. It feels like like if you were to describe what it was you were trying to do, is there like a really simple way to describe it without going too deep? Like not
Yeah.
the way that you described it, but just uh, a very simple description.
Yeah.
I guess there isn't a simple description, but I I kind of think of it as like I like if I want to create uh, a new thing and I want to encapsulate that particular code, but I don't want to define what it is. So kind of like if we think about an array, right? If I
Yeah.
want to throw a bunch of stuff in there, Like I don't define it at the beginning, right? Like this is generic languages,
Yeah.
not
Well, I think
specific.
the key
Yeah.
thing here is for languages that are statically typed, because that's like
Mhm.
where you start. Because you get this problem when you want to write a function, let's say, where you have to say the parameters of the function and the types of those parameters, and then also what the type is that it returns or types of things that it returns. So then now you're writing a function that requires someone to pass in, let's say, a string, and you can only provide that functionality for strings. But then, Jennifer, it's like you were just saying. Now, what if you want to provide the same functionality for some other type?
Right. So even going back is like addition. Like if you want to make
Mm-hmm.
it so you can add two floats or add two integers or an int and a float. I think this is like dredging up horror Ada land.
Yeah. Yeah. Well, for sure. And like taking plus, like you said, adding. What does plus mean for floats versus ints? And then throw in like strings or throw in arrays or lists or slices. Like you can define what plus means for all kinds of different types. It's kind of another feature of just the general idea of generics is not only can you let people pass in all kinds of different types, but you can also let them define different operations on those types. And that is a super, super powerful idea that is like the foundation of higher level types and traits and type classes and all kinds of crazy other things that maybe we can get into a different time, another time.
So someone says generics will probably reduce the noise for libraries and frameworks and consequently reducing possible bugs and maintenance. What do you think?
Good question. Why don't I start, Jennifer, and I'm going to throw it over to you for what you
Cool.
think as well. So for Go, Gustavo, I'm assuming you mean just for Go. Um, I would say for Go, definitely reduce the noise because right now the solution for generics or for allowing type polymorphism, meaning you can support many types with the single function or a single other type or whatever it may be. Um, it is done by generating code. So let's say I want to implement add, the function add. Well, you put a little comment above your function that says generate this code for floats and for ints. And now in the final compiled binary or in the final library that you provide to someone else, just depending on what you're doing, now you have two add functions. So that's two times the amount of noise, two times the amount of code. So yes, like of course, yeah, it will reduce the amount of noise and for libraries and frameworks. That's awesome. But Gustavo, yeah, it's like you said, if there's a bug in add, now there's a bug in two places. So reducing bugs as well. And then another thing is some people don't generate code for a variety of reasons. Sometimes they'll just write two add functions. And that gets tricky because now if I'm writing two functions that have almost the exact same code in them, well, there's obviously the problem of having duplicate code, and then there's the problem of how do I make it more generic, and bugs can just pop up at any point in that cycle. So that I think that touches on like maintenance and possible bugs and so on. But Jennifer, what are like what thoughts pop into your mind when I'm talking about all of these like reducing generic or reducing duplicated code and making things generic and so on?
It's kind of like it's what I feel is the case, especially thinking about when, like how the generics work themselves. Like, uh, if it happens that you're able to debug these things at compile time versus running into it in the uh, during execution during the runtime,
Hmm.
that you definitely can find these things earlier. And one of the DevOps ways is to do small changes and test early. And so when I think about being, it seems like a really critical feature that ops type folks when writing code want to know is like how to implement this early and have people implementing these early so that you can actually get that feedback early. Sorry, I kind of went off on a tangent there, but it's kind of feels like it's a critical aspect of languages to be able to when you reach a certain level of maturity in the language to be able to deduplicate code
Yeah.
within the language.
Yeah. Yeah. So Gustavo says it could work like overloading operators plus for numbers and strings and so on. That's cool. Yeah. I think it's cool too. Um, but one of the features for a lot of different systems that implement generics, not just Go, does allow you to overload various different operators, including plus. And that goes to what you said, Jennifer. You're duplicate or you're deduplicating code, but also you're giving the caller of the function some control over what exactly they want the semantic meaning for that operation to be. So, let's say you're doing plus and they're going to pass in their own custom type. Well, they might want to be able to not only say what does plus mean for their type, but also to be able to change that and then keep testing over and over again for their different possible like implementations of plus. It sounds like that is kind of in line with what you just said is like the DevOps way. I think that's pretty cool.
Cool. So do we want to start digging in? Now that we talked a little bit about generics and like what we understand, like I feel like I do kind of understand generics. Um,
Cool.
so maybe we'll
Yeah.
see.
Yeah, well, how about this? Let's dive into this proposal, or well, I'll call it a design document. It's probably better. Let's dive into that and let's just go step by step and then see what gaps we might need to fill in. Is that cool?
That sounds cool. Actually, I have another question.
Yeah.
So the way that the process for introducing new functionality like this is the process basically people think about it and a design doc comes out and then this like people test it in the community and then it's implemented for reals or like
Often,
what?
yeah. Often
Okay.
it's exactly that.
Okay.
Design document, um, prototype. If it's this big, prototype, getting feedback, and then based on feedback, going in and actually putting it into a version of the language. And then this thing at any stage of those steps, it can be like rinse and repeat. So like this design doc, I don't even know how many design docs there have been before this. I think it's at least two before this. And if you look at them, they have there's like an evolution that you can see. It's like an evolution in the syntax and the semantics on how you do this thing called type constraints, and a bunch of other things as well. And this author, Ian Lance Taylor, along with Robert Griesemer, they have gone through these iterations a lot. So they're like massive props to them for like sticking with it and putting out a design document and then going through that process of like gathering all the feedback and then finally getting to this point. And this would be, like you said, Jennifer, kind of the second step of doing a prototype.
Very cool. Yeah, it's like I was going back and it was like there's so much information about like this process and the bugs. Like it was so fascinating to go back, and it was kind of like I felt like I was going through all these archives and digging through. It felt like you could just feel the rich conversations that were had about the different aspects, and just so much thought put into this.
For sure. Yeah, and if anyone is in the Gopher Slack group, there's a channel in there called Generics, and that is, I don't know how long that discussion's been going on, but there's so much in there. There's so much like live feedback and living history as well of how we got to just this point, which I think is pretty, it's just pretty interesting to see how much brain power across X number of people went into getting to here. This is actually a really big point in time that we're here at a draft design document with a working implementation and a syntax that most people don't hate, which is good for computer scientists and software. Most people don't hate it, means it's great, as everyone probably knows here. Oh, so Dust the Dolphin. Yeah, today is not Friday. You are indeed correct. We are doing a Go focused thing today. So on Fridays, I do every Friday a screencast on the Crystal language. Today, we're doing a Go related one. I forgot to change the title. So thanks for pointing that out. I will actually change the title after this. So yeah, not this is the least hated syntax right now, and big win for us. So, what do you think, Jennifer? Should we go in and talk about this, or look at the code, or what do you think?
Let's dig in.
Okay. All right. So we've got an abstract here, and this is talking about what type parameters kind of means. So they're saying extend the Go language to add optional type parameters to types and functions. Type parameters may be constrained by interface types. And then it goes on. So let's just break down that first sentence. Optional type parameters.
I'm just like reading like what?
There's a lot. Like that sentence right here, that's dense, man.
Packed. It's packed.
So yeah, extending the Go language. Okay, I'm down. I like evolution of languages. Add optional type parameters to types and functions. So let's just take optional type parameters to functions.
Let's actually start with types. What is a
Okay.
type?
All right, let's go to a type. So I'm going to open up this thing called the Go Playground. You can go to play.golang.org. This lets you write Go without downloading anything to your computer. So I love this thing. And it's not only like, I don't only use it for teaching, it's like a scratch pad. Like I'll literally use it to just test out something. So if you don't know Go syntax, I will describe the syntax as I go, and we can just check out what is a type. So I'm going to make a new function. You start with func with Go, put a space, and then the name of the function, parentheses, the variable name, the parameter name, and then the type. And then at the end of the function, space, and then you put the type that you want it to return. That's the sort of basic crash course. So let's just return my var plus exclamation point. Just a really trivial thing. Okay. So a type is this. This is saying my var is a string. It can't be any other type than a string. So when you call my func, you have to pass in a string, even if it's the empty string. And then when my func returns, you get a string back, and you will never get any other type back. And if you assign the return to a variable, you have to use that thing as a string.
Cool. So, like, if you were linting this, if you didn't return a string or if you didn't send a parameter in that was a string. Is that a required parameter? Sorry, like this is like
It
newbie
is.
Go stuff too. This is awesome because this actually follows through on the function stuff you were sharing last week
Yeah,
about Go.
let's see this in action to answer that question.
Cool.
So, and then this fmt.println is how you print a thing in Go. So we're just going to print out my func return.
So I'm going to guess it's going to be ABC exclamation.
That is
So
correct. Oh
yay.
boy.
Oh, except
Syntax error. So when you declare a new variable, you have to do colon equals.
awesome.
Ooh, yeah, there we go.
Yay.
All right, so let's answer your question. Try to pass in 1, 2, 3. Cannot use 1, 2, 3, which is the type untyped int, as a string to the argument.
And it failed at compile time. That's
Correct.
cool.
And that's the key thing here is you have to abide by what the types of the function says they need to be. And if you don't, before you can even run the program, the compiler will tell you, nope, fix it. And then at that
Cool.
point, once you fix it, then you get a thing you can run. So that's like another layer of testing for you if you come from a scripting, like a Python or Ruby world.
Awesome.
So back to this. We know what a type is. So now what is a type parameter? So a type parameter is kind of like a function parameter, like this. Except a type parameter, instead of saying what the data is going to be, so this is setting the data that comes into the function, assigning it to this variable name, myvar. Instead of saying what the variable is, it's saying what the possible type of the variable is. So I'm going to use like a fantasy syntax. This is not the Go syntax. I'm just going to do a fantasy syntax because this might be a little bit more familiar if you come from Java or C++.
So you
Okay?
can do like pseudocode.
This is yes.
We're calling it fantasy code. Oh, awesome.
All right, yeah. Fantasy syntax. I like, yeah. I don't
I like
remember.
your fantasy syntax is like Sparkle pseudocode.
Yeah, let's see. There we go. There we go. We got a sparkle heart.
awesome.
All right,
Awesome.
so we're talking about type parameters. This is what a type parameter means. So it's saying, first of all, there's a function parameter, myvar. Okay, so inside of the function, you get a variable called myvar. But myvar is parameterized by t, which means that the type of myvar could change depending on who called the function.
Okay. Cool. I've totally done this in Perl in very bad ways. Awesome.
Nice, nice. Okay. So let me pause real quick. Gustavo has a question. I'm just thinking about type erasure in the way JVM does it. How could something similar work after compilation? Given a function, the compiler would generate all the type variations. What if I have a generic or struct? Sorry, I only skimmed through the specs. All right. So Gustavo, that is a very advanced question, and I don't know all the answers for you, but I do know that I am fairly certain, actually, that there is no type erasure. As the way that the JVM does it, there is no type erasure.
What is type erasure? Are we erasing types?
That is a question I do not know the answer to. I just know that type erasure I do not know the answer to at a low level. But I do know that type erasure means that in Java, when you are running your code at runtime, the function you're calling doesn't actually know what type is being passed in. So it's like at runtime, it's like this. Any type. Let me write that. At runtime, it looks like this. My var could be anything. That is type erasure. Whereas at compile time in Java, it does restrict the type.
No, it's these kind of questions are super helpful, Gustavo, because it helps us understand. For me, it helps me understand things that are not as well as things that are. Uh,
Yeah.
so thank you.
And for me, this really puts me on the spot, but in a really good way. It forces me to remember all of this stuff, and I really appreciate that too, Gustavo. Okay, I just saw this. Your question continues. Given a function, would the compiler generate all the type variations? What if I have a generic or struct? Okay, so I don't know compiler internals for Go as relates to type parameters. I am guessing that it does not generate all the type variations, though. I'm guessing that it goes through and figures out what types are being called and then generates implementation for those. I am I'm almost positive it's way more complicated than that. And that is just a guess. But that's my guess of like the fundamental how does it do it. And then what if I have a generic or struct? Structs are also supported with this design document. So we can do that as well. And then thank you for that link. I will go and let's see. I'm going to save that link for myself. Oh yeah, I can't do it here. I will save that link for myself later somewhere else for reading up on how type erasure works. Yeah. So Jennifer, checkpoint. How are we feeling?
I would like you to keep going on your fantasy syntax because, like,
Okay.
I feel like I am understanding. There was this certain thing that I would. I think this is the last time I used this kind of. I didn't know that they were generics. I didn't think of it as a generic at the time. I can't even remember what I called it, but it was something where I was like, I wanted to monitor something, so I'd written the script, but it was like it was similar enough, and so like I was piping in something that I hadn't defined at the beginning. So I think that's kind of what it is, but I'm still a little confused. Like if I look at this and I say like, here's the function parameters, totally understand those,
Mm-hmm.
and I understand what a type is. What I'm a little confused about is where the type parameter is, and
Mm-hmm.
is that actually part of the function, or is
Mm-hmm.
there something separate from the function where I'm defining types?
Gotcha. All right. Yeah. So this is an important one. That's a really good. That's a good question, but it's also interestingly worded. So I'll get into that. I'll get into that in a second. So the question you said, where is the type? Where are the types? Was that exactly what you said?
That's kind of what I'm wondering. Like, am I am I defining types here? Like, am I
Mm-hmm.
adding new types, and is that where the type parameter is? Right.
Yes. Okay. Yeah. So are you defining new types? No. This is saying that you can pass in any type to my func. So when you pass in my func123, you're passing in an integer. When you do my func abc, you're passing in a string. When you do
Right.
my func 123.456, you're passing in a float or a double or whatever it is in the language, in my fantasy syntax language.
So why is it optional type parameters to types and functions? Where is the optional type parameter?
So with Go, you can do this. So this function will compile, and in my fantasy language Go, my fantasy syntax Go, this will also compile. So the one that I just did before with the int, that is no type parameter.
Oh, that's actually helpful, is to have them both. Awesome. No type. Okay. Wait. Oh, okay.
So that's why they say optional. And they do that, well, they do that because Go has been around for 10 years with no type parameters, and now they're adding it, strictly adding it. They're also doing it because they want to be compatible with the old Go, the Go that is around right now and will always be around, and as long as Go is at version 1.
Okay, so there's a type parameter on the function in this line 9.
Yeah, exactly.
So how would you add a type parameter to a type?
So for a type, let me continue my fantasy syntax. So for a type, and I think I have this right.
Okay.
Yeah. Okay. So for a type, let's just
So
call it
something different. Got it.
exactly. So a function is like where you have your logic. A type is where you store your data, as we all probably know. So a type can have, obviously, it can have data inside of it. So that data has to have a type as well. So let's
So this is the newbie friendly station, so we're not going to assume anything about anybody's knowledge
yeah,
that comes in.
for sure. So
Sorry.
this is a struct, which you can think of as a bucket of data that every single piece of data has a name. So this one is my type is the type name of the struct. This is not a variable. This is a type. And
Yeah.
then inside of my bucket is a single string. So that's the data. And the name of that string in any variable that is a struct, is a my type struct, that variable will have a my var1 inside of it.
Cool. Can we make it a more not a real example, but something that illustrates what it is a little better? I was
Yeah,
trying to think of an example,
I've
like
got one for you.
structuring, yeah, address. Awesome. I was
There you
like,
go.
is it address? Like, it could, and this is totally US, potentially US centric, but like street number, street name, like, yeah.
We'll just keep it at that.
Awesome. Cool. Okay, so then where would a type parameter go here? Would that go inside in our pseudo fantasy syntax, or would that go at the?
Well, so let's think about for a second, like why, in what case, like would a country not be a string, or a number not be a string, or a street not be a string? So like I should probably rename this house number.
I was
So
thinking it's more like if something wasn't like if you wanted to structure your data and it's slightly different, but like if things are optional,
well,
are these required?
so these are all in Go. These are all, they have to be there, but they can be empty strings.
Okay.
So they are like the data will always be there as an empty string at least, but you don't have to actually say like what is the street if you don't want to put a street in your struct.
Got it.
So in this case, like it's hard to have an address without a street, but you could say nope, there's no, the house is not on a street, or the apartment or condo or whatever it is not on a street.
Oh,
So
that's a good example. Gustavo says country code, for example, US or 10.
yeah, oh, that's great. That is a perfect example. So that's where we would kick in and use our optional type parameters. So right now, all the types are fixed, string, string, string. And just like Gustavo, just like you said, you might want to have an integer too. I'll just make that a comment. So in that case, we're going to want to do this. So in the country, now, okay, it's not only always going to be a string, it's going to be something else. And the person who creates the struct, that's the person who's going to decide. Is it going to be a string or is it going to be an integer?
So then how would that get instantiated?
So in the first case, let's see the difference. Let's put them right next to each other. I'll just do it. This is the more conventional way. Let's say this is in, I think Germany is 39. Let's see, Jennifer's house.
Sparkle Lane.
Sparkle Lane. Okay, what's the house number?
I don't know.
456?
Yeah, 456 sounds great. I live at 456.
And then what country you want to be?
Canada.
Okay. Excuse me. Ooh. Pardon me.
Bless you.
Pardon me. Okay. So.
Don't get sick.
I will not. It's allergies. Windows open.
Oh, okay.
I'm actually going to not say untyped because that might mean something else. So this is with no type parameter. And this is with a type parameter.
Wait, but...
Not done yet, though.
Got it. I was like, wait, but I don't see it.
Oh, actually, I got this
wrong. It
wrong.
looks implied.
I got this completely wrong. There we go. So, this is no type param because we said it's a string. So it's a string. That's fine. With a type parameter, this is obviously not a string, so it's not this one because it said this has to be a string. But it could be this one because you can change the type of country when you create your new house, your new address. So in this case, just to be completely explicit, that is how you would say, okay, I want an address and I want the country to be an integer.
And if you have, can you only have a single one that has multiple options then?
You can have others too. So there are two ways to do it. Let's say you want house number to always be the same type as the country. That would mean that both are T, both are the same type parameter. But, okay, so let's pause there. So what do you think about this syntax? Is it making some sense?
It's totally making sense. Uh, I wouldn't want to do that,
Yeah, fair enough. Yeah.
but I understand why. I could imagine there could be cases that do this, and this is actually, I think Gustavo is asking the same question
Hmm.
here. More than
Yeah.
one attribute has generics,
Yeah.
which
So
is great.
so Gustavo says, what if one more than one attribute has generics? And it sounds like that was your question too.
Yes.
All right.
Yeah.
So let's say you want the house number to be either a string or a float for some reason. You can have a fraction of a house. I'm sorry, either an
It
int or
totally
a float.
happens. It totally happens. Well, it
Oh
could be
yeah?
a string or an integer. Well, yeah, no, like I've totally seen people implement code where it's a float. It's
Nice.
like, no, that's not right. Uh, yeah, yeah. So you probably want it to be a string, but maybe
Yeah.
somebody wants it to be an int. So string or int.
Yeah. All right. So, how do we do it? Let's actually just create a new one of these just so we can see how. Whoops. So, we need the house number to be something, but it might be a different type than the country, and that's the key thing, right? It's like we're asking more than one attribute has a generic type. So just like function parameters where you can have more than one parameter, like my var int and my other var string or whatever, you can have multiple type parameters too. And they're listed out just like you would expect function parameters to be as well.
Okay, cool.
And then you would put the u there. So now, let's say this is a fraction of a house. Oh no, not you, feedback hub.
Was it like 9 3/4?
Sure, let's do that. 9.75. So this is not right because now we have two type parameters. Let's we'll put it in here.
Wait, wait, why is it not right? Oh, got it. I see it.
Yeah, I've got two of these things. So the first one is going to be what the type of the country is because that's the T and that's down here. The second one is going to be what is the type of the house number. So let's say we want that house number, like we said, 9 3/4. We want that to be a float. All right. So this won't compile because the house number is not a float. And we want this to be 9 3/4, almost 10 house units. Now we're saying this address, this my fractional house, the country is Germany, and the Fantasy Lane house has 9 3/4 house units in it. And you can do this as many type parameters as you want. Depending on the language, there will be a limit, but it's you can usually do more than you need. And if you end up using up to like the limit, it's something is wrong, most likely.
So so if the way that it's like the plan for Go is, if I implement is my code going to look like this where it explodes out with each thing, or is there any kind of implicit anything? So if I don't specify a particular um, type parameter that it will understand. I guess it can't do that, right?
I don't remember for sure. Last time I read this all the way through, I am pretty sure that you can do this. And it can be implicit.
Cause, because you're saying like there's a float and there's
Yep, exactly. So then it will know, okay, T is an int and U is a float. And then it will know if you do this, And this is going to say I want to overwrite. I want to change the house number. If you were to make it a string, it won't compile. Because what it's doing here is it's saying, okay, my fractional house has a fixed type at compile time. And that fixed type is a string, a float for the house number, and an int for the country. And now you're trying to say that it's a string for the country, and that's a no-go because the compiler already knows, nope, it's an int.
Cool.
So when I write code that in a language that has generics, I try to be explicit like that. So I know that I can follow this down and I can say, all right, well, house number is a float. So if I follow this down and I say, oh, now I'm trying to make it a string, well, that's not going to work. It's easier for me to read that and really see it explicitly that, hey, this isn't going to work. And sometimes when you do this, depending on the compiler, depending on the language, this will give you way clearer compiler errors as well.
Right. I totally agree. Like being explicit rather than implicit is good for visibility and understanding. But one of the things we talked about at the beginning was duplication of code. And the way we have things right now, we have like three different definitions of address or
Yeah.
like modifying. So like then I'm kind of wondering. I kind of thought you could have the last one where it's like, oh, these are the optional parameters. Well, is there optional? And wait, so should there be a default?
You can break this back down and bring them all into here. So if you did this, and then you had house number U, country T, get rid of that comment. Now we're going to get rid of all of this and all of this. And then I'm going to just rename this back to address. All three will work.
Is there a way to specify that house number is like instead of having it implicit, like I'm gonna learn it from here, like I'm gonna say by default house number is a string, or
Up here?
yeah,
You
like
can't.
is there a way to say this is the default if it's not specified?
So you can't give it a default if it's not
Okay.
specified. Yeah, so let me start from the beginning. You can't give it a default if it's not specified. That's because house number has to be specified. Even if it's empty, it is specified at compile time.
So I guess what I'm saying, like there might be some technical term for this. What I'm wondering about is, okay, say I don't mean to change the type, and I'm assuming, but like unless I explicitly change it or explicitly set it, I shouldn't say change it, explicitly set it, but it sounds like it's kind of a little loosey goosey in terms of say like if it will figure it out if I don't specify it.
Yeah, it will infer it.
Yeah, infer. That's a great word.
Yeah, type inference. So it'll say here, I see a 1, 2, 3. I already do type inference on variables. So I'm going to do type inference on this struct field, this little data piece inside of the struct. And I'm going to know now that house number is an int, which means that in this case, is an int.
What if I accidentally forgot my quotes though? That's what I'm wondering. Like, what if I wanted it to error out unless I explicitly put the type parameter when I was setting it? So like passing address.
That's a good question. Yeah, that's a great point. So you can't, well, you can say, like, I want you to always be a string. That wouldn't, make sense, obviously, because if you want U to always be a string, then just put string
Right.
here. But you can do something called type. What do they call it in Go? I'm just going to refer back over here real quick. They call it type constraints in Go. So you can say that I want U to be like a string. And what this means is you're saying I want you to have these specific characteristics, these specific functions that you can call on this type, and these specific operations that the type provides. But it doesn't necessarily need to be an actual string. It just needs to be something that you can do those operations on. So let's say that like a string is, we have to specify what that means. I'm not even going to make a type, so.
Concatenate it.
Let's just say that. So like a string means you can concatenate, and then you can get an individual character back out, back out of it. So now, if I do house number is 123, you can't do this thing on 123, so this won't compile. Actually, none of these will compile.
Because we've gotten rid of all of our strings.
Yeah. But even if you did this, if you did, you want this one, the country is an integer, and this one is an integer, it's still not going to compile.
Right.
It's going to say no because you passed an int, but ints don't support brackets. So get out of here.
Cool.
So that's constraints. It's not saying exactly what you want it to be because that's not
Okay.
super valuable, but it's saying what is it what does it need to do? What does it need to be able to do?
Okay, cool.
And by the way, I think we just invented a new language. I think this is our new programming language, Fantasy Lang.
With extra sparkles.
Yeah. So Gustavo has some comments. So it sounds reasonable since there won't be so many type params in general. It's much more business rules. In this case, types are much more bounded and known. It would make much more sense for algorithms and things where it's generic, for sure. This makes cast useless. Sounds good. Yeah, oftentimes it does. And since you don't have to do type casts or type assertions, that means you don't have that risk at runtime when your code is actually running. And you don't have that risk that, hey, this variable might not be that type. So what do I do in that case? And then Gustavo says, so Gustavo, you're saying in that case, should they implement a common interface? Yes. Basically, this right here is my fantasy syntax of saying a Go interface. Having those common methods that you can call on U, on the type U.
That's super helpful that you've described it that way because I feel like some of the high level overview requirements actually talk about like interface types.
Mm-hmm.
And so I'm like, oh, okay. Way to lead into the other explanations.
Yeah, we have lots of different perspectives. Now we're tackling this from lots of different angles. It's pretty cool. And we're inventing a new programming language. It's also pretty cool.
So as you can tell, I have a dog and I have a 3-year-old.
Nice, nice. This is hashtag work from home, stream from home. I like it.
So fantastic.
All right, let's go back to the design doc and let's see if we can round out that first sentence here. Extending the Go language to add optional type parameters to types and functions. All right. So we did optional parameters to functions here and here. So this is with and without. And then we did types up here. This is a without, or actually they're all without the type parameters, but they all can have type parameters as well if you want.
Cool. Wow, we have managed to define the first sentence in this.
Well, we took that sentence and we blew it up into like every different possibility that you can have. And that's
It was wonderful
good.
and
Yeah.
amazing. Thank
Good.
you.
Yeah, for sure. So we actually also touched on the second sentence here too. Type parameters can be constrained by interface types. So we did that right here.
So that is an interface type.
Yeah. Basically, the way that this would be in Go is approximately there's a special syntax that they have in here on saying you can do plus and brackets. But I'm going to leave it like this.
That's
So
cool.
this is like this and this are the syntax for constraining a type.
Cool.
All right. So we are just about at time. And I will remember how far we got, and we can pick up here next time.
Awesome. This has been so fantastic, Aaron.
Cool.
Thank you so much for your patience and
Thank you.
allowing me to ask random questions about all of this.
Well, thank you for asking questions. Thank you, Gustavo, and everybody else in the chat as well. We will be back with Golang Mondays. Let's call it Golang Mondays. Maybe we'll come up with a better name next time. But for now, working title. Working title. Golang Mondays. We
We'll
will be
take
back.
suggestions.
Yeah. Suggestions, welcome in the chat. Or tweet me or Jennifer. Our Twitter handles are up in the header up there. Tweet us, put it in the chat, either one. We will be back with our working title Go screencast, same time, same place next week. So that's 11 a.m. Pacific time at this exact Twitch URL that you are on right this very minute. All right, everybody. Thanks for coming. Me and Jennifer both will see you next time.
Awesome. Take care.
Bye, all.